Okay, so I've had some technical difficulty. This is recording this again. So the least common multiple of a and b is going to be the smallest number such that it's the multiple of both a and b. The greatest common denominator is the greatest number such that it divides both a and b. So they're both just in the name there. And we can also, a lot of the time you'll have people talk about the least common denominator in everyday life. That's always just one, not terribly interesting. The LCM and the GCD are what we actually care about, and I'll try to use it correctly. So the simplest way to do this is to look at the set of multiples of A and the set of multiples of B and do the intersection of them. That's the common multiples. This is an infinite set, but we don't really care because we're just picking the smallest. So you just look at the first few and pick the smallest of the multiples. The GCD is a similar idea, but we would look at the set of common denominators of A and B, and that's going to be equal to the set of the denominators of A intersected with the set of denominators of B, and then we just pick the largest. And there's a few different ways that we can go about trying to find them. So for the least common multiple of A and B, we can look at the greatest common denominator of A times B and multiply that by A divided by the greatest common denominator of A and B times B divided by the GCD of A and B. Or you can cancel this GCD over here with one of the denominators, and then you're stuck with just you only have one division. So it makes it a little bit simpler. But so if this I'm not going to prove, but if you understand what's going on here, it should make a lot of sense and you should be able to prove it to yourself. So be aware of that. The least common multiple, there's a few other ways that we can go through and solve this. So that is the other way we can go through and solve it. But we can also just do essentially what I was talking about up here and look at the list of each of these guys. So I can do 3, 6, 9, 12, blah, blah, just list out all of the multiples of 3 and then list out all of the multiples of 4 and then look at the intersection of them. So pick out the first element that's in both of these lists. And these guys, they're not really necessary for me to list because I know that the LCM of AB is going to be less than or equal to A times B. So because this is definitely a multiple of both A and B, I know that it's going to be less than or equal to that. The least common multiple is going to be less than or equal to one of the multiples. I could also do the other method that I said, but this isn't terribly interesting in this case because the greatest common denominator of these two is just 1. So if I list out the denominators of 3, that's 1 and 3. If I list out the denominators of 4, that's 1, 2, and 4. So I pick out the greatest, and that's just 1, which is the most trivial of them. We call these guys coprime. So if GCD of A and B is equal to 1, they are coprime. So in that case, I get 1 times 3 divided by 1 is just 3, 4 divided by 1 is just 4, so 1 times 3 times 4 is 12. So that checks out here. A slightly more interesting case is if I have the GCD of 4 and 6 is equal to 2. I can see that by dividing out here. So I do 1, 2, and listing out the divisors, 1, 2, and 4, and 1, 2, 3, and 6. So that gives me 2 as the greatest common of divisors. The only common divisors are 1 and 2. And in this case, I can do the list method for the least common multiple, and that gives me 4, 8, 12, 16, blah, blah, all the way up to 24. I know that I can stop listing at 24 regardless of what else is on these lists, because that's multiple. That's what's the product of these two guys. And so then I have 6, 12, 18, 24. So if I want, I can compare these lists, and I see 12s on each of them. Cool, that means that's 12. That's the least common multiple. But I can also do 2 times 4 divided by 2 times 6 divided by 2 is 12. So this, guys, also remember this is equivalent to A times B divided by GCD of AB. So this is a third possible way to write that. They're all the same. Basically, I'm making sure that I don't double count their common factors. Another way that I can find the GCD is by listing out their common, or their prime factorizations. So the prime factorization here is, so if I have the GCD, I already have the prime factorizations of both A and B. So the A is 2 to the 4, 3 squared, and B is 2 cubed, 3 cubed times 5. I would just say, okay, I can pull out 3 2's from both of these guys. That's just the smaller number of 2's that are shared. And then I can pull out 2 3's from both of these guys. That's the smaller number of 2's that are shared. And then I can only pull out 0 5's. So you can think of this as having an invisible 5 to the 0, but no point in listing that. So the GCD of these two numbers, I don't actually know what they are. You can calculate for yourselves. Would be 2 to the 3rd times 3 squared, and that's going to be equal to 72. So that's another possible way to calculate the GCD. But for all of these guys, I need to know basically what the prime factorization or the list of common denominators is, or something along those lines. And that's pretty hard to calculate. It's easy when I'm dealing with 1 or 2 digit numbers, but what about here when I'm dealing with 2 different 9-digit numbers? I don't know what that is off the top of my head, but I do have a pretty good system for checking that. That's called the Euclidean algorithm. So if I have the GCD of A and B, this is how it's listed in your textbook. We can also just remember, hey, we can just, if you don't want to go through this whole process, just remember you're always dividing the bigger number by the smaller number until you get to 0. Once you get to 0, the other number is just your GCD, or is your GCD. So if I want to do the GCD of 18 and 4, then I would do 18 divided by 4, and that gives me 4 remainder 2. So now I'm going to replace 18 with that remainder 2, and then I would do, what's the GCD of 4 and 2? Well, I would divide 4 by 2, and that gives me 2 remainder 0. So I would have the GCD of 0 and 2, which now I'm checking here. That says A is equal to 0. So my GCD, so I can return B, and that tells me that the GCD is 2, which you should be able to check this guy. So this has 1, 2, 3, 6, 9, and 18. That's everything, right? Yeah, that's everything. And this is 1, 2, 4. So 2 is the greater of the only 2 denominators here. So not that. So that is, sorry, I'm having some trouble associated with a storm here. I'm going to end this video because of that.